Bismillahirrahmanirrahim. Assalamu alaikum students. Here is the syllabus in front of you. Hope so you are all doing well from all aspects. Today we will discuss the numerical problems of chapter 2. The statement is: a train moves with a uniform velocity of 36 km per hour for 10 seconds. Find the distance traveled by it. A train moves with uniform velocity of 36 km per hour. So we will write given data. The velocity is 36 km per hour. We will convert this velocity into meter per second because the SI unit of velocity is meter per second. So as we know that 1 kilometer is equal to 1000 meter. So we will multiply it by 1000, and as you can see here is per hour, and 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So 1 hour will be equal to 3600 seconds. So we will divide it with 3600s. You can see here these two zeros, 36 will be cancelled with 36 and the remaining will be 10 meter per second. Velocity will be 10 meter per second. This is also your MCQs of chapter number 2. Now, from the data, the time is 10 seconds. We have to find the train distance that it traveled. To find distance, as we know that speed is equal to distance over time. Time is divided here, it will be multiplied with speed on the left side. So S will be equal to V multiplied by T. Now we will put the values of all the factors that are, as we know velocity is 10 meter per second, the time is also 10 seconds. We will multiply these two factors. 10 multiplied by 10 will be equal to 100 meter. Hence the covered distance by the train will be 100 meters. This is your first numerical. Let's start the numerical, the problem 2.2. You can see from the book the statement is: a train starts from a rest. A train starts from a rest, so the initial velocity will be 0 meter per second of that train. Now it moves through 1 kilometer. You can see the distance is 1 kilometer and the SI unit of distance is meter, so we will convert kilometer into meter, and you know that 1 kilometer is equal to 1000 meter. In 100 seconds, in 100 seconds mean the time will be 100 seconds. What will be its speed at the end of 100 seconds? We have to find the final velocity of that train. We know that the first equation of motion is Vf is equal to Vi plus At. You can see that Vi is 0 meter per second, the time is 100 meter per second, but we have not the factor acceleration. To find the acceleration, we will use the second equation of motion. As we know that S is equal to Vit plus half At square. By putting the values from the given data, the distance is 1000 meter, initial velocity is 0 meter per second and the time is 100 seconds. Half acceleration, we have to find it, and the time is 100 seconds square. You can see that this will be same. 100 multiplied by 0 will be equal to 0. Half acceleration 100 square will be 10,000. You can see that 2 ones are 2 and 2 5s are 10. This will be equal to 5,000. The 1,000 is equal to 500,000 multiplied by acceleration. This factor is multiplying here and it will be divided with 1000. You can see that these will be cancelled and you can put 1 divided by 5 in your calculator. The answer will be, the acceleration will be 0.2 meter per second square. You can see here 1000 is as it, 1000 is as it, and you can see here this will be multiplied with 0 and the answer will be 0. 2 ones are 2, 2 5s are 10, 5,000. Here is it is multiplying, either will be divided. You can see here the acceleration will be 0.2 meter per second, as acceleration is found here. So by using first equation of motion, which is Vf is equal to Vi plus At, by putting the values of initial velocity, acceleration and time, as we know that the velocity is 0 meter per second and the acceleration is 0.2 meter per second square, the time required, that is 100 seconds. We will multiply 100 with 0.2, the answer will be 20 meter per second. Hence the final velocity of that train will be 20 meter per second.